A pension plan model exists from employment using the following triple decrement model. We have 3,000 active lives at age 60. At exact age 61, 20% of the active lives retire. No retirement occurs between integer ages. The force of transition from stage 0 to 2 is 0.05, and from stage 0 to 3 is 0.02. We want to calculate the number of individuals expected to withdraw between age 61 and age 62. Okay, so currently we're at age 60, and our goal is to withdraw sometime between age 61 and age 62. So that means we have to survive age 60. So that means we cannot withdraw, we cannot die, and we cannot retire. Okay, so retirement occurs at exact age 61, and that's 20% of the active lives. So retirement happens over here. And you can withdraw or die anywhere in this interval. So let's look at the entire probability. Right? So let's look at P60 tau. So you want to these will include all the decrements. So it's the independent probability of retiring, withdrawing, and dying. So retiring, there's a 20% chance that you'll retire. So there's 80% chance that you won't retire. Now, let's see, the probability we withdraw, the independent probability we withdraw is e to the negative. Let's see. We want to look at the force which going from stage 0 to stage 2, which is 0.05. And that's 1 full year, so we're basically multiplying the 0.05 with 1. And then for being dead, we're looking at the force of transition from stage 0 to stage 3, which is 0.02. And we're not going to multiply it by anything because we're only looking at 1 year. Okay. So then the total probability of surviving age 60 becomes 0.74592. Okay, so now we're at age 61. Retirement is good. So we can't retire now because retirement only happens at integer ages. So we want to withdraw between age 61 and 62. So retirement is out of the picture. So the only thing we have to worry about is we can either withdraw or die. So those are the only two decrements. So what we're really looking at right now is Q61 and then decrement 2. So by definition, this is the integral from 0 to 1. Total probability at age 61 of surviving. And then multiplying by the force of transition at age 61 plus t. Okay. So this is a key step. So we're looking at the total probability. Right now, we said we do not include retirement. So in the total probability, we're not going to put a retirement. So we're going to include withdrawal and dead. Withdrawal is 0.05. Dead is 0.02. And we're going to multiply by that t. And then the force of transition from stage 0 to stage 2 is 0.05. So we're just going to multiply that. So now we just have to integrate. And let's see, so that's 0.05 e to negative 0.07t over negative 0.07, going from 0 to 1. Plug it in and get 0.04829. Okay, so that's the probability that we withdraw at age 61. But currently we're at age 60. So we have to first survive age 60, which is this probability, and then we can withdraw, which we just found to be 0.04829. So if we include both of these probabilities, we just have to multiply them and also multiply by the number of people, right? So there were 3,000 active lives. So the probability of surviving age 60 and then withdrawing the next year would be the product of these two. So we can combine it all and say 3,000 times 0.74592 times 0.04829. Final answer is 108.06.